So this is going to be the second video of this kind of playlist, I guess it'll be, of just different covalent bond properties and everything like that, and Lewis structure. So as I said, this is by no means in depth into Lewis structures. This is just the basics, the steps, and a couple of exceptions. But if you're good on Lewis structures, if you're good on the basics of Lewis structures, good on the steps, feel free to skip this video and go on to the next one, which will be a little bit more in depth about Lewis structures, formal charge and resonance and things like that. If you need a little bit of help on that one, go to the next one. Won't hurt my feelings if you skip this one. But that being said, if you're not 100% on the basic steps of the Lewis structures, I would definitely just watch this video. It shouldn't take too long. I'll try not to talk as much. And just take notes on this. Remember, take notes on questions that you have. Take notes on important things that you need to remember, so you can kind of progress in this unit. So we're going to start with Lewis structures, and we already kind of defined it above. I guess not even defined it, but we just kind of talked about it a little bit above in the last video. And so here are going to be the basic steps for Lewis structures. We're going to count up total valence electrons in the molecule using periodic table for help. So what this means is just that having each column which coincides with a certain number of valence electrons. So in this case, if we go back up here to methane, to CH4, we see that just in this, pretend this isn't even here, and we're trying to draw the structure of CH4, of methane. So carbon, I know has 4, and if you don't know, that's totally fine. Just go and you'll use your periodic table for help. That's what that means. So carbon has 4, hydrogen has 1, but we have 4 hydrogens. So that means we have 4 times 1, 4 plus 4. So we have 8 total valence electrons that need to be in the final structure. Okay, that's good to know. We're going to put that off to the side. If I had a pin right here, I would write out 8. So I'm just writing it invisibly. Okay, so next step, we see place central atom in its appropriate place. So least electronegative atom except for hydrogen. And we know I kind of stressed that up here. So we're going to put carbon right here. So carbon's going to be the center with 4 H's on the outside. And same with down here, we look at a little bit more complicated one. This is iodine cyanide. Oh my goodness, that is a tongue twister if I ever saw one. So this is iodine cyanide. And cyanide, is one of those polyatomic ions that you guys have to memorize. So we see that carbon is going to be the least electronegative one here. Carbon is going to be the least electronegative one here. We can't have hydrogen in the middle, so carbon is going to be in the middle. Okay, so now place a single bond between each atom, which represents 2 shared electrons each. So we're gonna have our central atom. We're gonna put them on out there, and then have a hydrogen. This hydrogen singly bonded to this one. This hydrogen singly bonded to the carbon. So we know that if these lines, right, these single bonds represent 2 shared electrons each, and we know we have to have that 8, right, that we calculated, the 8 total valence electrons in each, total valence electrons in the structure. Let's count these up and see how our number matches. So we know we have to have 8 total, so let's count this up. 1, 2, 3, 4, 5, 6, 7, 8. So we're done. We have 8 total valence electrons, 8 total valence electrons in what we calculated, and so we're done. Not only that, we also have carbon having a full octet. Carbon having 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. And H and H and H and H, all of those having the full outer shell that hydrogen has. So we're done with methane. But if we weren't done with just at the third step, we would go on to the next one. Fill the octets of each outside atom first. Then if there are extra, place them with central atom. So I probably could have worded that better, so I apologize for that. But I'll kind of explain it a little bit more as we go down here to this compound. So fill the octets of each outside atom first. So what this means is, let's just start out with, let's say that we didn't have triple bond over here. Let's say we just had carbon singly bonded to a nitrogen. Same goes over here, but that's already singly bonded. So we would have, this would go away, right? And we would have 2 dots up here. This dot would go away, this line would go away. 2 dots would be down here. Let's just say we don't even have dots. Let's just say we kind of got to this step right here. Just a line between each atom. So we would just have I, just a lone I, line, C, line, N. So we would need to have, so we know that iodine has 7 valence electrons, right? 7 plus 4 valence electrons, and we're up to 11. 11 plus 5 valence electrons, then we're up to 16 total valence electrons that need to be in the structure. So we would have remember, we're imagining just bare eye, just a naked eye over here, line, C, line, N. So then we would have 2 valence electrons, 2 valence electrons. So we would have 4 valence electrons already drawn in out of the 16. So then we would have 12 left to kind of play with, I like to say. So then those 12 left that we play with, right, these are fill the octets of each outside atom first. So we would have 12 left, and then everyone would, you put those out here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this guy would have, this guy would look like this guy over here. Again, there I am again, personifying atoms by calling them guys. But he over here would have 1, 2, 3, 4, 5, 6, 7, 8, because that single bond right there represents 2. So that guy would have a full octet. This guy over here would have 1, 2, 3, 4, 5, 6, 7, 8. So he would also have a full octet. Now, here's where we run into the issue. So we would have 16 full, so we wouldn't have to worry about if there are extra placed on the central atom because we wouldn't really have any extra. Ensure the full octet of central atom with double or triple bonds if needed. So if we had a single bond here, that would leave carbon with kind of alone, right? That would leave him with only 4 valence electrons. That's not a full octet. So what we would do then is we would take a pair of electrons on nitrogen, make them have a triple bond or a double bond, right? Because we wouldn't have this line right here yet. And then we would see that then carbon would have 1, 2, 3, 4, 5, 6. So he's getting closer. He doesn't have a full octet yet, but he's getting closer. And then we would just steal and not steal, but we would take another pair from nitrogen, bond them with there, make them have a triple bond. 1, 2, 3, 4, 5, 6, 7, 8. Carbon has 8. Iodine has 8. Nitrogen still has 8, right? 1, 2, 3, 4, 5, 6, 7, 8. All we did, if we go back up here, all we did was just rearrange those valence electrons, right? And this was ensuring stability of carbon. So that's how that one works. Now we get down to Lewis structures of polyatomic ions. So it's just a quick little additional step. And we know that the symbol indicates the addition or subtraction of electrons. NH4 positive 1. That means we subtracted, if we go back to algebra, we subtracted a negative 1, giving us a positive charge. So instead of having 9 valence electrons, right, 1 nitrogen with 5 plus 4 hydrogen with 4, giving us 9, we would focus on the singular plus 1 charge that tells us that we have lost, that we don't have an electron. So we have 8 total valence electrons. So then you use only 8 valence electrons when you're drawing your structure. The same goes for a negatively charged polyatomic ion. And I really like this image right here because it kind of shows you step by step what to do. You start with a single bond. And then you go down here. And it looks like I only have 30 seconds on this. And then you place it out there with the negative 1. So we'll get into more depth later on with a couple more videos, resonance structures, exceptions to rules, and tips and tricks about more stuff. Oh, and also formal charge. But yeah, so I'll see you soon. I don't know what I'm doing. All right. Well, it's going to end. See ya.